This is question 9. It starts off with a probability tree. We just need to know that each set of branches have to add up to 1. So if that's 0.067, the other one has to be 0.993. You take away from 1 each time. The very bottom one has to be 0.992. Sorry, 22. And if we look back up, it tells us there that the probability that someone who has diabetes gets a correct positive result is 99%. That's 0.99. If it's positive for having diabetes, and then that means that this has to be 0.01. And then we're going to multiply, so you're going to do 0.067 multiplied by 0.99, that gives you that there, and then you do 0.067 multiplied by 0.01, and it'll give us 0.0007. And then we multiply the next two, it'll give us 0.0728. And multiply the next two, it'll give us 0.8602. So the probability that a random person tests positive, so they can have it and test positive, and then they can not have it and test positive. So it's both of those things added together. So it's 0.0663 plus 0.0728. And that will give us 0.1391. Person picked at random tests positive for diabetes using this test. Find the probability that they actually have diabetes. Well, it's given that that they do that they have diabetes, or that they test positive. It's given that they test positive. So it's going to be all of the people that test positive are on the bottom. So 0.6, sorry, 0.06 um 63 plus 0.0728. That's all of the people who test positive on the bottom. And people on top are the people who have it, or we'll say have diabetes and test positive. So that would be 0.0663. Will give us 0.4766. Part B of the question then, this is going to be using the kind of binomial probability. It's work out the probability that two or more. So for two or more, well, if it's two or more, then we're going to do 1, take away the probability of 0, take away the probability of 1. And then that would include if it was exactly 2, or if it was exactly 3, or if it was exactly 4, or exactly 5 or more. So that's what we're going to do. So it's going to be 1, take away, and then we're going to fill in the formula for 0. So that would be 5 choose 0. The probability of it happening, that's the 6.7%, or 0.067 to the power of r, that's the power of 0 times, and then we have to do 1 take away 0.067, that's 0.993 to the power of 5 take away 0, that's 5. And then we're also going to take away 5 choose 1, and we're just filling it in the same as we did. 0.993 to the power of, it'll be 5 minus 1, that's 4. And then we can go to the calculator. You might have to work some of those out separately. It's 0.0392. Right, this one then is just how many different combinations of 10 people can be picked in Group A. So you have 20 people and you're choosing 10 from it. So it's just 20 choose 10. And you can use that NCR button. So 1, 8, 4, 7, 5, 6. Right, second part, it's just going to be 10 factorial. If you think about it, if you put 10 boxes here, if you imagine that that's the first person there, so we're just taking, this is Group A, we'll say. So Group A are all going to choose a person from Group B. So the first person would have 10 different people to choose from. Then the second person gets to choose. There's only nine people left to choose from because one person is gone, and then there's 8 people, 7 people, 6 people, 5 people, 4, 3, 2, and then the last person only has one person left. They have to take whoever is left then. So that's just one way of looking at it. So it's 10 factorial. So it's going to be 3, 6, 2, 8, 8, 0, 0. Right, this part then. So I have to look at it slightly differently here. So there's 8 people in first group and then 16 in the second group. So if we just take each of those 8 people, okay, so 1, 2, 3, 4, 5, 6, 7, 8, so 8 people. Each of those people are going to choose 2 members from the group, from the other group, from Group Y. So that's Group X. And then this is going to be Group Y. So when they're choosing, there's 16 people in the group, and there's going to be 2 people that they're choosing. And then when those people are chosen, it's going to go on, and there's only going to be 14 people left, and there's going to be two to choose. And then so same kind of way as up above, it's just slightly different because there's different ways of choosing the 2 people. And then it's going to be 12 choose 2 for number 3, and then it's going to be 10 choose 2, 8 choose 2, 6 choose 2, 4 choose 2, and then the last one, only people to choose, but they're going to choose two. So there's 2 different ways of choosing them. And then we're going to multiply them all together. So a way of thinking about it is if you just look at the last one, there's there are 2 people left, but there's still 2 different ways of choosing them. So you could choose first one, then the second verse. So and then if you were to think about the second last one, there was 4 people left there, but they're going to choose 2. So it's that many ways of choosing them. So you're multiplying all of that by each other. So it's going to give you something very big, obviously. It's 8.2 times 10 to the power of 10. You have to round off a little bit there as well within that because they want it in standard form. So it's a tricky enough question now that, but it's the last part of a 50-mark question to do with probability. So they have to make it a little bit, we'll have to make it awkward.